Hello and welcome to our 6th CPD session. In this one we'll be examining Resource Pack 6, Evaporation and States of Matter. If you have not yet looked through the topic's resource pack, we would recommend that you do so before continuing with this video. The link is available in the description. Now that we've thoroughly examined the material, let's go through the resources for this session. The basic outline of all of these resource packs can be found within the teacher guide for each. However, we would like to stress that these were not written with the intent of being read verbatim. So feel free to be creative with the material, adapting it to your own unique teaching style, and have fun. For this lesson, we begin by clarifying the pupil's knowledge of the mechanisms of evaporation in order to ensure that they won't be lost in the specifics of terminology later in the lesson. Now we move on to the specifics of the different states of matter and their physical properties. We then link this to the bulk of this lesson by examining some elements of an Earth analogue, the Makgadikgadi salt pans in Botswana. This leads into a group discussion on how these vast salt pans may have formed. The mechanisms for the formation of these salt pans is then shown in video form. In this video we have a saturated salt solution being evaporated and depositing crystal sodium chloride. From previous lessons, pupils should have an understanding of how the surface water on Mars would have evaporated due to low pressure and the supersaturated saline bodies which would be affected by this phenomenon. We therefore now have a group discussion on whether life could exist in these harsh salt pans like can be found on Mars. Then we examine the idea of microorganisms which are resistant to salt desiccation and could potentially survive under these conditions. Lastly, we close out with a few questions linking back to the session in order to reinforce the subjects taught. Join us next time for our final session on the resource pack for Lesson 7, pH on Mars.